All right, folks, here's a recap on today's lesson. Okay, today's lesson is just the power rule. It is very straightforward. Okay, so let's say you have this function over here. In order to find the slope, aka tangent, aka derivative, the old way, you can use any of these methods here. But I'm going to teach you today is called the power rule. It's a shortcut. Okay, so what we're going to do is, all right, we're going to move the 4 over to the left and multiply it by the 5. So you are going to get f prime of x equals to 20. And then you subtract 4 with 1. Okay, so you do 4 minus 1, and you get 3. Okay? And that is your derivative formula, aka the formula for any slope. Now you would get the same answer doing it this shortcut way, which is called the power rule, compared to if you do it this way or this way with x plus h and with x and h's or x and a's. Okay? Now let's use this same method here. Okay? If I move the 3 over here, okay, invisibly there's a 1 here. So f prime of x rather, is going to be 3x squared. Okay? Also, if I do the same thing here and I move the 5 over, okay? If I move the 5 over right there, I'm going to get 40 x to the power of 4. Okay? So the 5 moves over and gets multiplied by the 8. And then you do 5 minus 1 to get 4. Okay? Over here, the first thing to acknowledge is that all of these oranges are equal to each other. Okay? This is obvious, okay, because there's a 1 right here. Here, anytime you see an x on bottom, okay, you can rewrite it as x to the power of a negative exponent on top. Okay? And this goes without saying, square root of any numbers to the power of 1/2. If this said cube root, then this would be 1 over 3. Okay? Conversely, if this said 2 here, this would say x to the power of negative 2. Okay? Anyways, now, if you want to do f prime here, you're going to get, right here's a 0, excuse me, a 1. So you move the 1 over here, and you get 1/3 x to the power of 0. Okay? Which essentially equals to 1/3 times 1, which equals to 1/3. All right. So again, the 1 moves over to the left, gets multiplied with the 1/3, and I get 1/3 here. Okay. And then 1 minus 1 is 0, and anything to the power of 0 is just a big 1. 1/3 times 1 is 1/3. Okay. Here, okay, same logic. Okay, same basic logic. I'm going to move the negative 1 over, and I'm going to get negative 3. Okay. And I'm going to get x to the power of negative 2. Okay. Because negative 1 minus 1 is negative 2. Now, to write this properly or to simplify it, what you should do is this. And then over x squared. I should write it as a vertical fraction with x squared truly on the bottom here, but just ran out of room here. Okay? Now here, okay, f prime is going to equal to, okay, this is so important because it's so common, so I want you to, in the end, memorize this. Okay, but I'll show you the steps in the middle. F prime is going to be 1 over 2. And then you get x to the power of negative 1/2. Okay? So 1 over 2 moves to the front, and 1 over 2 minus 1 is negative 1/2. Okay? Now, let me actually type this up on Symbolab. Okay, just so you can see it as a clear fraction. So I had 1 over 2, and then x to the power of 1 x to the power of negative 1/2. Like that. Okay? Now this is going to move to the bottom, and the negative is going to change to positive. Okay? So anytime you see a negative exponent, you can move the stuff to the opposite side, in this case from top to bottom, and then change the exponent from negative to positive, which is what happened here. Okay, this essentially equals to 1 over 2x, like that. So let me copy and paste this. And we essentially get this right here. Okay? All right. Now, let's keep on going. Let's say you have something that looks like this. Okay? The first thing I want you to acknowledge is that these two are the same, basically. These two are exactly the same. Now, I want you to see how, this became, when you take the derivative, let's start easy. This became this when you take the derivative. And then when you take the derivative using power rule, also this becomes that. Okay? The 2/3 moves to the front, 2/3 minus 1, which is 2/3 minus 3/3 is negative 1/3. Okay? And then I want you to see how this orange becomes that orange, because again, anytime you see a negative exponent, move it to the opposite side, in this case from top to bottom, and change it from negative to positive, which is what happened from here, this gray to that gray. Okay? Now, x to the power 1/3 is basically cube root of x. Okay, and then we're done. Here, okay, y equals to 5. All right. I want you to see how these two blue highlights are exactly the same. Okay, because x to the power 0 is 1, 5 times 1 is 5. Okay, and then when you move the 0 over to the front, 0 times 5 is 0. 0 minus 1 is negative 1. 0 times anything is 0. So f prime is a clean 0 here. Why is that the case? Because y equals to 5 is a horizontal line. Okay, and look at the slope of this horizontal line is just a clean 0. Okay, that's the only new part. From here on out, it should be pretty straightforward. Okay, well, it was already straightforward, but it should be kind of review. Okay, this word says tangents right here. Okay, determine where blah 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 blah. You can read that on your own. When you see the word tangent, you think the tangent is slope, which is derivative. So I'm going to take the derivative using the power rule. Okay. Now, when you see horizontal, you just think to yourself the slope is 0. So I'm going to set this equal to 0. Okay. Factor and solve. You get 0 and 2 for the x coordinates. So you can rationalize it this way. At x equals to 0, x equals to 2, you have horizontal tangents, which is confirmed by this graph right here. Okay? You have horizontal tangents. Okay? Now, if you want to find the remaining y coordinates, okay, you just plug in this green 0, green 2 into the original y, or original f of x. Okay, and you get the 0, negative 4. All right? Again, I see the word tangent here. So I'm going to do the derivative okay? And it's asking for the derivative of x equals to 2. So I'm going to plug in 2 in for the x and get a slope of 12. Okay? All right? So we have a function x squared plus 8x in red right here. Okay? And we want to first find the slope, which is the slope of this green line. Okay? We find that out to be 12. Okay? So we're going to plug in 12 in for there. Okay, point slope form. We're going to plug in 2 in right there. And for y sub 1, I'm going to plug 2 in to the OG, to the original f of x, and I get 20. Okay, so 2 squared is 4 plus 8 times 2, which is 16. 4 plus 16 is 20. So I'm going to plug in 20 in for y sub 1. And then add 20 to both sides, and I get this final answer. Okay, so the equation of this green line, y equals to mx plus b, is basically this. And if you distribute this, if you distribute the 12, you truly, and then combine like terms, you truly get a y equals to mx plus b format. Last example is right here. Okay, this was original function from the original example from last week. So last week on Friday, we can see this is continuous, so that it passes the continuity test. But we can see that it does not pass the tilt. It has a tilt issue basically. So we know that this is not differentiable at x equals to 2. However, we need to prove it using algebra, the official AP Calc way. So what we did was, well, we know this is a linear function. So y equals to mx plus b says the slope is 2, okay, for the left side. And we try doing it on the right side to see if it's equal. And the right side, we use the x minus a alternate definition, okay? All right. And we do some fancy pants algebra over here, and we get -4, okay, which does not equal your 2 that I circled, so we know it's not differentiable. There's a shortcut, though, using this new power rule, okay? If you use the power rule on the original 2x right here, okay, invisibly there's a 1 here. 1 brought over times a 2 is 2. 1 minus 1 is 0. X power 0 is 1. 2 times 1 is 2. Here, okay, use the power rule, you get 2x minus 8. Okay, that's for this parabola. Then you plug in 2 into x. 2 times 2 is 4, minus 8 is -4. So your slope over here of the parabola at x equals to 2 is -4, which does not equal to the original, to the 2 coming from the left side. So you get -4 does not equal to 2, which is not differentiable, which is the same thing we got over here using the old method from Friday. Okay, I just feel that I think you would agree that using the power rule is faster. Okay, that's today's lesson, folks. Thanks for tuning in.